Hello, everyone. Welcome back to the Microcontroller Application Technology course. Today we will learn about 8-digit display dynamic scanning. Next, we will focus on the following 5 aspects. In today's lesson, you should understand the principle of multi-digit displays, the principle of dynamic scanning display, know how to connect a dynamic scanning display circuit, and grasp the basic structure of program design, completing the simulation function of showing the date on an 8-digit display. I believe many of you have electronic devices like scales and digital clocks at home. Digital clocks not only provide us with time information but also allow us to set alarms, and some even display room temperature and humidity. Starting today, we will use a microcontroller to design a digital electronic clock. The 3 basic requirements are as follows. If you successfully learn this, it means you have officially entered the field of microcontroller control. For this lesson, our main task is to complete the design of the time display for the digital electronic clock, which involves showing today's date on an 8-digit display. To display the year, month, and day simultaneously, we need to use an 8-digit or even more digit displays, as a single display can no longer meet our needs. However, the microcontroller does not have enough ports to output segment codes. Therefore, we need to resort to dynamic scanning display. First, let's see how multi-digit displays work. This is a common 4-digit display available on the market, which comes in both common cathode and common anode types. This is a physical pin diagram with a total of 12 pins. Pins numbered 12, 9, 8, and 6 are the common terminal pins, corresponding to the common terminals of the 1st through 4th displays from left to right. The other 8 pins correspond to segments A through G and the decimal point, DP, of each display. Now, let's take the leftmost display as an example for explanation. Its common terminal is pin 12. Since it is a common cathode display, ground pin 12 of the 4-digit display to activate it. Here, sending the segment code for the number 0, which is 00111111 or hexadecimal 3F, will show the number 0 on the display. Similarly, the common terminal for the rightmost display is pin 6. When this common terminal is connected to ground, sending the corresponding segment code will display the corresponding number. The 8 displays on the physical circuit board consist of 2 such 4-digit displays installed together. This is an 8-digit display in the simulation software, and the principle of its display is the same as that of physical displays. Next, let's take today's date, July 29, 2024, as an example to illustrate how dynamic scanning display is achieved. Controlled by the program, we first enable the leftmost digit display, send the segment code for the number 2, and display the number 2. After a period, we enable the second display from the left, send the segment code for the number 0, and display the number 0. After another period, we enable the third display from the left, send the segment code for the number 2, and display the number 2. Following this pattern, we sequentially display 4, 0, 7, 2, and 9. Then we start the display process over again, continuously cycling through. As long as we control the interval time well, ensuring that the total time for one complete scan is less than the human eye's persistence of vision of 0.1 seconds, it will give the perception that all displays are showing numbers simultaneously. During the scanning display, the control code that controls the corresponding display is called the bit code. In this example, we use port P2 for control. The code corresponding to the character displayed on each display is called the segment code. It is controlled by the microcontroller's port P0. This way, only 2 I/O ports of the microcontroller are needed to achieve simultaneous display on multiple displays. Below is the connection in the Proteus simulation circuit, which is the minimal system of the microcontroller. This is the part with the 8-digit display, using common cathode displays. It is worth noting that on the physical circuit board, there must be a transistor drive or other driver chips between port P2 and the bit codes of the displays. Otherwise, the brightness of the displays will not be sufficient. Now let's analyze the program, which is divided into two parts: the main function and the delay function. The main function's role is to select each of the 8 displays from left to right in turn, displaying different numbers, and it loops continuously. The purpose of the delay function is to implement the delay between the switching and displaying of every 2 displays. Let's check the program in detail. First, there is a one-dimensional array that stores the segment codes corresponding to numbers 0 to 9. When using it, the array elements are accessed for use, and the delay function is declared. The program starts execution from the main function. The dynamic display program is divided into 8 groups, with each group consisting of 3 instruction lines. Select the first display from the left, showing the number 2. After a delay, the next display is selected, and the character to be displayed is sent, continuing in an endless loop. Below is the delay function. After compiling without errors, a HEX file is generated, which is then burned into the microcontroller, and the displayed content can be seen. In today's lesson, you should have grasped the display principle of multi-digit displays and understood how to use dynamic scanning to drive multiple-digit displays. If you want to display 199008828, how should the program be modified? Finally, please reflect on this lesson and complete the following exercises to consolidate the knowledge learned today and further deepen your understanding. That concludes this lesson. See you in the next lesson.